welcome to Tech to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I'd like to introduce KYZEN's own Shawn Varney.
Hey everybody, welcome to this week's Tech to Tech. We'll be covering the troubleshooting series here, and our topic here today for us is troubleshooting on a batch cleaner. Quick overview of what we'll be going through. We're going to go over a couple of the best practices for reliable performance, what to do if my parts are not clean, and the top 5 steps of troubleshooting. So let's start from the beginning here. What is a batch cleaner, right? So you'll see a picture on the left, kind of looks like a dishwasher, might look a little familiar with what you have at the house, but it's a little more advanced. It's a closed loop system for cleaning electronic assemblies. It could be printed circuit boards, it could be wave solder pallets, it could be many different things that you can clean in here. It uses chemistry or chemicals and a rinsing stage to remove any flux of residues and contaminants. It's an enclosed process. It offers better control and consistency versus a manual cleaning process, where you might have some variables with humans, right? So this will have timers and stuff set so you can just be consistent. Batch machines are used as also for a great benefit, a smaller footprint. Maybe you don't have as much throughput either. So where an inline washer takes up 30, 40 feet, this might be only a 10 by 10 area or so, depending on what size batch washer you go with. So how does it work? There's 3 main stages here, right? So you have a wash, rinse, and dry. The wash stage is going to be chemistry. It's sprayed and it could in the chamber, and it's at a controlled temperature. Helps remove those flux residues. You have the rinsing stage, which is next. So it'll swap over, drain that chemistry out, fill up with some DI water, and then start rinsing. You could have multiple rinses too in this stage. And then you have your third stage, which is drying. So it's the drying stage really is to eliminate moisture by heating up the air. You can regulate the exhaust too, how much it's pulling out to regulate that temperature, and pressure too, how strong the fans are going and whatnot. So common signs of trouble that you might see when you have your batch cleaner. On parts, you're going to see visual residues, maybe water spots after cleaning. You have longer than usual cycle times. You're going to have some maybe irregular noises or frequently alarms that are going off all the time. So you don't want that. That's the machine warning you that something's going wrong. You might have sudden shifts in the cleaning performance. So what a batch machine does is you might have had something before, an old cycle that was running great, and then all of a sudden today it's not. So that's something we need to look into for if we have signs of trouble. So troubleshooting step 1, the visual inspection. This is important, right? So you want to check cleanliness of the chamber itself, where you remember that picture that looked like a dishwasher. Look inside there, see if there's anything that's in there that might be stuck, some residues. You might have some spray nozzles that need to be checked for clogs. You have filters on the backside of the machine that you want to go through and change. You might want to look for some blockages, broken parts. There might be some parts on the bottom of the chamber, or for some wear. So you might see something wearing on the side of the wall. You might see some bearings wobbling or whatnot. Those are good indications of some troubleshooting you need to take care of before it goes bad. Early detection of mechanical issues prevents bigger problems down the road. Step 2, verify your parameters, right? Confirm your spray pressures are right. Look for temperatures, might be off. Maybe the heating element's not getting to temperature. Your timing matches your specifications. No one's changed any settings in there and whatnot. Parameters can drift and change accidentally. Operators might log into something, change a time here or there because they think they're bettering the process, but that's going to affect your cleanliness level, right? Something you want to watch. Compare your actual performance to a standard recipe. So a lot of these batch machines come with a standard recipe, certain times, dries, rinses. You can change those. Everybody's different is what I would tell you. Find the parameters that work well for you and modify them from there. Sometimes you want to work with both machine manufacturer and the chemistry people because they have a little different preferences on how the chemistry might work or versus how the machine might work. Find those boundaries and mix them. Get the best parameters you can for your process. Troubleshooting step 3, chemistry condition, right? This is a big one. So verify the correct chemical concentration using the recommended method. So there's several different ways depending on your chemistry. Examples are like a refractometer, uses light. You look through a sight tube, and you can change that into a chart and tells you your concentration, right? You have titration, almost like you do at a pool. You're doing drops to figure out what your concentration is, or you have a split method. So if you look on the screen on the right-hand side, that orange area, that would convert into a percentage. Check for changes in color and clarity of the solution, the chemistry itself. That can be some indicator sometimes. Sometimes it might turn colors, depending on if you're using masking and stuff like that. It could change it. But a big note here too is just because the chemistry is changing colors is not a bad thing. That can be very misleading too as well, as a bath might look like it's soiled, but it's still cleaning effectively. So you might have process controls in place that check your cleanliness. Just go by those, and as long as you're passing, you can send out a bath analysis to your chemistry provider too, and that would help you determine your bath life too. So under concentration can be bad because you reduce cleaning, right? You might have some residuals left over. But over concentration too, high percentage of your concentration of chemistry could be bad as well. You could remove some coatings off some parts, labels, stuff like that. So you want to be at your set method within a plus or minus 2 range is probably a good indication of where you should be. Step 4, rinse water quality. So this is a big one for me, right? So monitoring conductivity for DI water is a basic standard here. There's IPC standards you want to go by. You can always do a little better than that too. Poor rinse quality causes spotting or ionic contamination. So we want to make sure we rinse all that chemistry off too. When you get to that point, the biggest thing I'd say with this is, remember, you're only as clean as your final rinse. It's just how clean you're going to get your board. You want to be extremely clean at this point, so you're leaving nut water spots and whatnot. Regular monitoring of your filter replacement can help and be essential with this as well. Step 5, troubleshooting. Drying effectiveness. This can be involved with a couple different steps here, meaning that inspect drying stage for proper function of the fans, the heaters, and the exhaust. So maybe the fan's not blowing at the speed it needs to be. The heaters, maybe you have 2 heaters and 1 heating element's down, or the exhaust is too strong and it's pulling all the heat that you're generating out of that chamber. Look for wet boards. Wet boards can be risky, meaning that they could get corrosion on them, or they could have recontamination or spotting. It could be just a visual effect too, but customers don't like that either. There could be a possible second step to this, right? So maybe the batch machine doesn't get it as dry as you want it. There could be a second process like baking your boards after you come out. An example of this would be like a vented BGA. Doesn't have usually 2 holes, it'll have 1 hole. Chemistry or water will get in there. Once it's in there, you need to try and get a longer dryer time or bake out time to get that water, the DI water out. So a little case example of this, you might see some white residue on a wave pallet. This is a customer we had. Their issue, obviously, you can see in the pictures before and after, white residue on pallets after cleaning. The cause is that we had a reduced concentration. They weren't monitoring their concentration correctly or enough times, and their concentration dropped low. Also, the rinse temperature after rinsing was too low as well. Hotter temperatures rinse a little better, flattens that water out so you can get it off, right? Get all that chemistry off. The solution, pretty easy, right? Get the concentration back to where it needs to be, that plus or minus 2% range, and then get your temperature back up on the rinse, and you can see the after. It's a big effect. Just monitoring your process is key. Preventive maintenance matters, right? So regular checks of spray arms, the pumps, the heaters, the filters, that's a big thing. PM, preventive maintenance. Check your chemistry log and concentration. You could keep a manual log of this daily. Just depends on how your throughput is. Sometimes you can check it every couple days, depending if you have low throughput. If you have high throughput and that thing's running all day, you might want to check it once or twice a day at the beginning of each shift. Clean the machine weekly. Some machines even have daily clean and check. Some of the batch cleaners have a screen mesh at the bottom that they want you to vacuum out to ensure the solder balls or anything else that's at the bottom doesn't get sucked in on the intake on the pumps and hurt the pumps, right? We want to keep the machine running as smoothly as possible. Preventive maintenance just improves the uptime and reduces any kind of major problems or troubleshooting. Helpful tools for troubleshooting here. So tools that can help you out. These aren't limited to this. There's just a few that we came up with that you're going to use on a daily or regular basis. Again, your refractometer, the titration kit, or the split kit. That's going to help you for that concentration. That's a tool you use all the time. thermometers or a probe for checking temperatures would be great. You can put it in the wash bath, you can put it in the chamber, make sure the heaters are getting where they say they're getting to. Second verification never hurts. Conductivity meter for your DI water. You might have a probe meter on the machine, which is great, or you might have one down the line and you just want to check it on secondary. Log sheet, like we just talked about, log sheet's huge. You want to make sure that this is kept up to par so you don't run into any problems. Another way KYZEN offers it's what's called an Analyst 2. It's a automated digital way of checking your monitoring your concentration. So it's a screen. There's an output of your temperatures and the concentration. It checks it every couple milliseconds. That way you can see a live reading when the wash pump's running. Another one I found super handy was like a smoke detection sticks that you can use for door seals. It's a little stick. It's not flammable. It's just, you have a generator too. You can get an electronic one. Puffs a little smoke. You move around the door seals. You can see where you maybe have a leak or exhaust that you might have. It's a great way to use one too as well. So summary key takeaways. Don't forget that a systematic approach simplifies your troubleshooting every single time. So stay with your 5 key takeaways here. So number 1, visual inspection. 2, you verify your parameters. Step 3, check your chemistry. Step 4, monitor rinse quality. And step 5, confirm your drying performance. So frequently asked questions on this topic. So question 1 here, how often should I check my chemical concentration? You should check it, depends on your throughput and how often you use the machine. If you're running 2 and 3 shifts a day, that could be something you want to check at the beginning of every shift. Some batch machines, most all of them, have a little bit of a dilution rate, meaning that when it swaps over from rinse back over to wash, there'll be a little water either left in the chamber or maybe in the pipes that gets shifted back into the chemistry, and it dilutes a very small amount over time. So if you're only running 1-2 batch loads a day, maybe you only need to check it once a week. So it just depends on your throughput. Question 2, what causes white residue on pallets after cleaning? The most common sign that I see here is your concentration's too low and your temperature is probably too low as well. So that's a big thing. Even I've seen on printed circuit boards, white residues usually mean concentration issues. So use those titration, split method, however you use for your concentration checks. Question 3, why is rinse water quality so important? It's the most important step to rinse everything off for spotting, for visual checks that the customer likes. You need to get all the rest of your soap off that might have some ion in there that would cause contamination, right? We don't want dendrite growth, so you're only as clean as your final rinse. We want to rinse all that off and make sure we have nothing left on the board and get a proper drying so it's perfect, clean, and crisp. Question 4, how can I tell if the drying stage is working properly? Well, you can have obviously visual check when it comes right out. If you see it dripping wet, drying time's probably not long enough or the temperature's not hot enough. You can have the boards that can sit out for a while, and maybe down the line when you go to do some masking or some conformal coat, you'll see some spotting or white residue or chemistry or something come out from underneath parts that will give you an indication that something's wrong in your process, that you're not getting washing or rinsing, drying long enough. And with that, that's all I have for you guys today. Thank you for joining this troubleshooting series. I will turn it back over to William. Thanks, guys. Bye.
Thanks, Shawn. And thank you guys for watching this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local KYZEN regional manager or send an email to tech@kyzen.com, and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.